Give you a number, 1500 Newton meter per second is my rise rate of this vehicle, and same is fall rate. So slew rate, for whatever words you want to use it. And why I am telling this number? Because if I don't put that much of torque on the wheel at that rate, vehicle will roll back at any point in time, because you have to maintain. If you go to the gradability test as per AIS or even UNEC, then the gradability test essentially asks you to be at 20%. They literally stop the vehicle here and then they ask you to drive further. Or so now you can imagine even a millimeter of movement backward and a two-wheeler standing behind. You imagine what happens. It's simple moment, not velocity. It's a moment of inertia will kill that person. Right? So torque management, I was mentioning to you, coefficient of adhesion, torque management is very critical for this vehicle. And why I chose this example rather than giving you all that theoretical V equals to IR calculation, because this is a pragmatic example available in Asian continent, doing all these juggleries, or I will say tricks of the trade, to make sure that vehicle is up, smoothly running, charging fastest and smoothest drive pleasure, and so on and so forth. So effectively this is what that vehicles are all about. And if you pass by noise, we call it, there is another criteria we call pass by noise, because if you see Ather, Ola and all that things, right, so you don't hear that noise, because electric motors noise per se is practically in 10 dBs or 20 dBs. So you and me are talking at 40 dB, your IC engine at 100 plus minus dB, or with all this padding and NVH mechanisms in place, you are at 80 dB, but these vehicles are at 20 dB. So we have to add vehicle noise management system so that nearby person literally knows that yes, vehicle is passing by. So quiet the experience is. So still I will say in electrical locomotives our compressors are working hard for braking, because you have to maintain that pressure. And to give you a number here, 13 bar is a common pressure as far as compressing that air circuits and cooling systems are concerned, because without that you will not able to stop the vehicle if you go to the braking test of the vehicle, or neither you will be able to accelerate the vehicle. So lot of things are there which essentially deals that.
Very comfortable. We are now entering the city center. Putrajaya City, which was developed as the people escape governmental building, is the prime electronic losses circulating through the city region. Turns to Central Station. Central. In about 30
So these are
minutes,
the, as I said, there are charging bays if you see.
turns to
Stop.
Central Station.
So there are charging bays, 3, plus now pantograph charging down is also there. So total 5 to 6 charging bays are there. Okay. So when we, because then now you know all electrification things are, everyone is beating the drum. But the fact of the matter is that for electrification, 2 things are really required. One, your grid should be extremely stable. And to give you an example, all your doubling work, the first thing they did is that they first erected traction supply substations. So if you go anywhere on this track, even you go to Mirror's yard, you have 25 kV, 4 MVA stations like manned across the track, and average length is 25 kilometers. So every traction substation, the distance between 2 consecutive substations is 25 kilometers, because you have to haul VAP 6, VAP 7 kind of locomotives. P stands for your passengers.
With a super quick charging system at the Central Station.
So as I said, this is pantograph up. There is pantograph down also. Right now I don't have video, but this is pantograph up system. As I said, fully automated. No one is even looking at it what that pantograph is doing. But all functionalities and are taken care of. And cable ampacity itself is 1000 amperes. So if you see your wrist like that, there are 2 cables pulling down from that to the battery compartment. Right? So total weight of the vehicle and cable, if cable vehicle is let's say 23 tonner or even 17, this is 17 tonner vehicle, the cable weight itself is 400 kgs. So think of copper just went in with that gauge to make sure that system really works without a drop between charging point to the battery point, because we all know KCL KVL. So I will not go into that KCL KVL that you guys are master of. But that drop calculations from charging point, that is that upper tip of the connection till the battery point where you are literally receiving the current, because from there also there are 8 battery packs connected in parallel, 8, 6 depending upon configurations of the vehicle. So all these battery packs shall not have different SOCs. So branch currents, we know that for branch current we need to maintain the resistance equal as a function of temperature and so on and so forth. So branch current also we maintain to the level not more than 1 ampere between two branches. So in total summation of I is less than or practically 0, meaning you don't, difference of I is 0, and summation of I equals to 800 amps. So that's how we maintain that tolerances. So under any circumstances, even vehicle to vehicle, so now I call it as a part to part variance, is practically less than 1 ampere. That's how these vehicles get charged, that's how that batteries get managed and cooled down perfectly. So sensor accuracy, control loop accuracy and architectural accuracy, all this system of systems accuracy, all put together, we have such kind of experiences in place.
Charging is completed in just 10 minutes. The bus will then run the approximately 30-kilometer route again. In this demonstration, we will confirm the running performance of super quick charging ready electric buses and verify the battery service life and super quick charging.
So I was mentioning to you, right, battery's performance is directly proportional to the region in which it is operating. So if you see LTO battery packs, you have widest range possible, -20 to 60 degrees. You go to Toshiba's website, you will get. You go to LG's website, you will see NMCs are very good at 25 degrees C or 35 degrees C to be precise. But when it comes to the cooling system, we have to maintain that thresholds, let's say 25 degrees C or whatever that your tropical ranges are. And when I say tropical ranges, you have to maintain the temperature even it at winter, that means you have to put warm jackets, and in summer, that means you have to put cooling chillers. So we call it as a battery thermal management system. It is not your AC cooler that you just feed it. It is not a IC, so it is not just heat evacuation technique. It is heat generation technique also we have to provide here, so that batteries really balance out perfectly. Internal impedances of the battery packs are leveled and SOC is different, is not more than 1%. So we use Coulomb counters here to capture the SOCs.
Performance during continuous operation in the tropical region. Therefore, the setup includes a system to monitor the conditions and operation status of the electric buses and the installed batteries. In addition, subsequent plans called for the advanced demonstration of large double-decker electric buses, which are...
So, as I said, this is 17-tonner bus, that is 23-tonner. The gradability is 20%. Double-decker architecture is around 700 volts. Both architectures are developed here. I mean, developed by the people sitting in Pune, not somewhere else. That is the good part or bad part of it, I don't know. And both are pantograph-based charging system. This is 320 something, that is 480. So, all put together 2 megawatt at any point in time. Yes, Malaysian government gave awards for this project way back in 2022, because this is one of the projects, and we are still struggling. If you see, India is still struggling how to roll out electrical buses. We are still buying buses outside, but yes, being a small country, they are doing such kind of job. So double
It's
decker.
difficult to convert to electric buses due to weight constraints.
So you know
Utilize
why, how we are now talking. So see, I am now connecting the dots. I have to first understand the road infrastructure available. What is the payload that road can absorb? Can I put double decker? Yes, and when I was in 4th or 5th standard, Sangli used to have double decker, Miras Market to city bus. I used to travel that. Now double deckers are closed, and in fact, but that double deckers were not that heavy. Now I can correlate. At that time, I never had anything knowledge of that. But now these double deckers are, I will say, ballpark 18 ton. This is 23 tonner. So The base, why we developed 23 tonner, because we want to carry 93 passengers in one go. That is my capacity allocated to that. And why so? Because we want to remove the good amount of vehicles from the road. That's what even railways do that, and still give you the good amount of velocity. So intra-city and intercity commutations, that has to be managed properly. Otherwise, come to Pune, you will realize that 26 km is 2 hours. That is the situation right now I am facing. Forget about anyone else. So unless we go for such kind of public infrastructure again, which was anyway there, it is not that we are again reinventing the wheel. I mean, practically we are reinventing the wheel. So infrastructure was there, we lost it. Now again it's a high time that we go back to such kind of systems where, number one, we improve the haulage of the vehicle, or I will say total people per trip, we call it a trip efficiency, improve it. Number one. Number two, make sure that you are really sustainable. So another aspect of electric vehicle is point to point transport, number one, and reducing the pollutant matter in the air at highest density point. Because if you go to Vishrambag, that's Vishrambag right now, whatever it is, it was not like that. We never had an issue of, I could not feel now it's a fresh air, it is all about smog coming in. So that difference I am seeing even in Sangli and Pune, means what I used to. So that essentially tells me that now pollution levels are rising and we are already on that air quality index, we are deteriorating. Even Sangli topped the list. That was very surprising to me, but it has happened. So that effectively tells me that to reduce the vehicle pollutions on the road also, we have to go for electric, number one. Number two, same time we have to improve the haulage per vehicle. So get rid of, I will say, the individual vehicle movements, and come to, because there never used to be like this, you know, we used to come by bicycle. So that is how it is, and that is how we have transformed ourselves into the more automated work, because this is automated vehicles nowadays, quote unquote. But yes, it came with, each technology comes with its own advantages and disadvantages. So disadvantage is that you are polluting, and advantage is that your average speed has gone up. So average velocity, or I will say travel time, has come down. So this is, you have to balance that. So drivetrain electrification or electrification of transportation system and everything is a part of life, and I would suggest that these are the silent points that we need to look for.
Using Japanese technologies while working in collaboration with local companies, NEDO aims to create more intelligent infrastructure by improving the efficiency of Putrajaya's transportation system. In showcasing this project, NEDO also aims to
You just go to PPT. So I have prepared PPT out of all these things: how to develop battery systems, how to do monitoring, putting safety controls in place. Looking into the time, I don't know how much minutes left for me, but yes, this is very heavy PPT. Go through it. It essentially covers the vehicle level requirements, then battery safety standards that RECC compared, then battery system architecture. When we talk about any system, one has to understand the use cases. So if by chance, if any one of you had a chance to go through ASPICE, okay, recent release of 4.0 or 3.0 for that matter. So on the top left, we call it as a SYS1, SYS2, which essentially defines your system engineering. What needed, why needed, what are the use cases, what are the safety cases one need to do, and so on and so forth. And top right, it's a validation cycle, like how you literally correlate those. So one is your, and then the tools, means, because we know MATLAB, we know VCUs, we know microcontrollers, so I will not dwell into that, but these are the tools essentially to achieve that use cases, using this tool to achieve the user experience. So left is your system engineering, understanding why that resistance is required or why that MOSFET is required, and on the right side, make sure that it works as per the guidelines allowed. Yeah. So I mentioned that these are the typical vehicle classifications, what are the masses and all that thing. So anything above 5 ton is M3. All this PDF will be anyway given to you, so you guys take care of it. Energy consumption in kilowatt hour per kilometer, I am again mentioning. These are all available on the literature. in the literature, sorry. And whole idea is that power driven motorcycle, so you know your classes, so most of the time we use two wheelers, right? So your cylinder capacity and everything. So if you recall, our RTOs don't request you to produce any license if your engine capacity is less than 50 cc, so it comes from here, right? So these are all norms that effectively drives your vehicle, and these are certain definitions I would emphasize here. One is C rate, essentially Coulombic rate, how much charge discharge we pull out. E rate, energy. Then secondary and primary cells, we are into the secondary cells because we are charging and discharging. Capacity, C rate as specified, and nominal energy. So when we are talking about WH, right, that is where the issue starts, because 100% of state of charge to cut off voltage. So let's take an example of NMC. NMC starts at 4.2 fully charged and depletes at 3.3 or 3.2 depending upon the scenario. Yeah, so why this is required: open circuit voltage, internal resistance, because when you are characterizing your energy system, it is not just per se energy system that drives the vehicle. It's internal, because you are carrying IC engine and your fuel tank in that battery box, right? And plus your some electrical fuses and service disconnects and whatnot. So all these chemistries essentially drive the system. So again, here is a typical chemistry type. I have avoided giving the name of the manufacturers. In fact, incidentally or accidentally, I used to work on these technologies way back in 11, now it is 24. We characterize NMCs, LTOs. There are IEEE papers on that, just check it. All these characterizations we carried out to make sure that what is the life expectancy arriving out of it. So finally it is like a bucket of water, right? But bucket of water don't have any resistance. This bucket of water has a resistance, and which changes as a function of, it's a aging effect, it changes. So if you go to the rain flow counting or any stress management cycle, you will realize that your internal resistance will go up as a function of time, because of it's a characterization, it's a characteristic of the system. In fact, why your blood pressure goes up, because